All right, Tom's here, we can go. I'm Mark Carlson, I work for Toshiba Memory, and this is Paul Suhler.
I work for Micron Technology.
And we're here to talk to you today about some new features in the upcoming NVMe standard. The abstract that hopefully got you into the room is we're going to talk about, if you're part of the NVM Express organization, TP 4052. And 4052 is in a state that is pre-approval, pre-ratification at this point because we're waiting to coordinate with other TPs as we get integrated. So, this are smiling faces. So we're going to talk about NVMe capacity entities. We're introducing and up-leveling some of the previous concepts in NVMe. We'll talk about some of the use cases for this work and give some detailed examples. And then we'll drill down into the actual commands and what's sent back and forth. So, as I mentioned, is TP 4052. It's endurance group and NVM set management. This project kind of follows on the I/O determinism work that was finished last year, wherein you can take a drive and split it up into smaller sort of virtual drives that don't interfere with each other if you do it right. And what they punted on for I/O determinism was having some way to manage or configure those NVM sets and endurance groups. So the current I/O determinism envisions NVM sets and endurance groups being created in the factory by the vendor and coming to the customer already pre-configured with the NVM sets that he wants. However, that's not very flexible and doesn't allow you to repurpose drives into other use cases, etc. So that was the original impetus for this work. The other sort of impetus for this work was, you may have heard about Open Channel or Project Denali, and there the desire is to do almost all of the flash translation layer up in some host as part of the software-defined storage or other databases up there would understand the layout of their data on the underlying media in a more detailed way. To date, SSD manufacturers haven't wanted to expose that information. They don't want you to know what the architecture is behind their controller. But there's obviously market and use cases for this, so we want to keep that in the NVMe standard and not have it be a competing standard. Does that make sense? So we address the need to divide the work between the host and the drive. So with this particular feature, you now have a knob that you can turn that says, no, do everything in the drive, or turn it the other direction, do everything in the host, or you can put the knob in the middle somewhere and say this part needs to be done by the drive and this part is reserved for doing in the host. So that kind of flexibility then allows us as SSD manufacturers to ship one drive to all our customers and have them figure out how they want to configure it, whether it's for a Denali-like application or the I/O determinism use cases that I was just talking about. And as part of this, we've promoted endurance groups from just a single little number in your NVM set to a broader concept that's reused for use cases outside of I/O determinism, outside of the Denali use case. Allows you to manage your capacity in a room-sized NVMe device as well by using endurance groups to carve out capacity from the underlying domain. Oh, what are domains? Well, domains were introduced by TP 4009, but we picked them up, and this is the reason why we both have to go into integration. Right, Mike? At the same time? Mike's our integrator for NVMe back there.
He keeps us honest.
Yeah. All right, any questions so far? We'll cover a lot of this in more detail. Okay, so this is the capacity entity hierarchy, and I can't wander over there. That's right, Mike's right here. But namespaces are as they have been, unchanged. However, there'll be new types of namespaces coming. If you went to Bill Martin's talk this morning, you saw what's happening in the key value space. So key value namespace will be a new namespace type. But also ZNS. If you go to a ZNS talk today, ZNS is a new namespace type. And so this is agnostic. This work is agnostic to whatever namespace type you want. You can have various namespaces types within a single set. There's nothing that prohibits that. And then NVM sets still exist. They haven't been promoted. In order to create a namespace, you need an NVM set. And if you configure it right, those NVM sets will be on different channels on the back end. We'll just talk about that in a minute. But then there's endurance groups, which I mentioned are sort of promoted from a single number that the manufacturer configured at the factory to now you have control over what your endurance groups cover. And endurance groups are a way for, at least in the current NVM 1.4, they're a way for the drive to tell you what the drive is wear leveling and what it's wear leveling with. So you have an endurance group across two sets. That means that the drive is managing the wear across those two sets so that those two sets will wear out at the same time. And this was a requirement coming in from a bunch of different groups that endurance groups needed to be more flexible. So now we're giving control over endurance groups to the host. Previously, it was just drive to host. Here's what I did. Live with it. Now you can come in and configure an endurance group and then add NVM sets to that and compose those NVM sets with the fine details of what's in the back end as well. So you'll see that new functionality. And then I mentioned domains. Domains are a way to divide up the capacity within your system. You may have back-end trays behind your controller that are one sort of domain. And so if you have multiple trays behind your controller, you might have multiple domains that you advertise for them to create their own endurance groups and sets out of. Any questions so far? This is a basic concept. Yeah, Mike.
One point of clarification. The NVMe working group is deciding whether the namespaces that live within a set can only be of one type or mixed type, and that decision hasn't been made. So people are wondering, come and join us.
Right.
Help decide that.
Yeah, we are recording this, so I got to clarify that question. Mike pointed out that we haven't actually made a decision on whether we can have multiple namespace types, but none of this work precludes that, I think is what I said. Okay. All right, so this is the original NVMe SSD organization. And before, in previous work, we were not exposing these media units. Now, what is a media unit, right? Media unit is kind of the finest granularity that the drive is willing to expose to you for separate wear level management, okay? So it could be a die, it could be a plane on a die, or it could be any future concept that any media comes up with. But the idea is the drive is going to wear level at this finest granularity, and it's up to the host to tell him if he wants to wear level more than that, within a set, within an endurance group, etc. So that endurance then is part of this knob I was talking about. How fine-grained do you want the drive to be with their wear leveling? By default, most drives today, they wear level the entire set of media behind it, right? They don't give you the option. IO determinism gave you the option of sort of wear leveling on each NVM SAT separately, but then the host would need to wear level across sets. And this exposes that underlying media units behind and what their configuration was coming out of the factory. So in this diagram, a media unit is one of these little white boxes. A channel is that thing that connects them. And a channel is just a communication path between the controller and the back-end media. Because if you have two sets or two namespaces that are using the same channel, they're going to conflict. One's going to delay the other. And for some customers, this is not acceptable. Right? They want their separate workloads to hit separate pieces of media on separate communication paths on the back end in order to get predictable quality of service, especially in the read latency. The long tail of latency is when you go to read something and it takes a long time for it to come back, less than the handful of microseconds that it would normally take. And what that causes is all sorts of problems at scale. And at scale, I'm talking Google, Facebook, Amazon, Microsoft Azure. That kind of scale has multiple requests to the storage that are somewhat serialized and somewhat parallelized. But if any one of those takes too long, it delays the next tier. That means your web page doesn't come up with everything filled in yet. And maybe one of those things that didn't fill in is an ad from a Facebook customer. The real customers, not you. And because that ad isn't displayed to the user, he can't charge the customer for that ad view, right? And the customer's off doing something else before he gets the data back to run that ad. And of course, the more people that Facebook can show this ad to, the more revenue they get. So it all depends on that little SSD in the Facebook data warehouse as to whether they can make that revenue. And that's a big deal for these big companies who are doing this at scale. Okay, any questions on this? All right, I'll cover this in the next use case and then turn it over to Paul. This is the IO determinism use case where each NVM set is its own endurance group, just like they're shipped from the factory today. But now you get to see visibility on the back end, and you don't have to keep it configured this way for the life of the drive. You could repurpose it over into a Denali use case or whatever. But typically this is done when you first get the drive in. You would configure it this way for this kind of application. And in this example, you would have 4 separate workloads against this one SSD, but those individual workloads are not conflicting with each other because they're all hitting separate media on separate channels. And this is how you get the predictable read latency. There's also something in IO determinism that allows you to window between different modes. One mode will give you predictable latency and hold off a bunch of background work that needs to happen until you put it in this other mode that allows the background work to continue on, do wear leveling, garbage collection, patrol reads of the back-end media, etc. And then the supported media unit configuration is something that is part, and Paul dig down into that a little bit more, but you could ship a drive with 2 supported media configurations. One is 1 terabyte sets, and another media configuration is half terabyte sets, because we get both numbers from different hyperscalers. This allows us to ship 1 drive to all hyperscalers and cover all the IO determinism use cases. And that's what we mean by the SKUs is the worst possible case for a drive vendor is to have custom firmware, custom SKU for each hyperscaler out there, and the customers that are trying to use the hyperscale model as well. So we don't want to make it so that you have to have a conversation with your customer as to how your drive is configured, and then have a factory procedure for configuring it that way for that customer, because that causes a nightmare in support and testing and QA and everything else. So that's part of the goal here as well. And then the host managed media users, they don't want to drive to wear level anything except within one media unit. So you can create a configuration like this where every media unit is its own endurance group. It has one NVM set in there. Maybe there's only one namespace within that set as well. But then the host is keeping track of the wear on each piece of media here and is able to direct its writes to the least worn piece of media that it's going to start using. This does require a lot of work in the host to do this, but what that allows then is you to optimize the wear leveling at more of a system type view rather than the individual drives. Individual drives wear out. The system doesn't wear out, right? You want to hide drive wear from the customer. You don't want him to see an error because your drive is wearing out. So you want to be able to move that up into the host, look at it as an overall system, and then optimize whatever you're doing with each of those drives based on what the global needs are of that system. Any questions before I turn it over to Paul?
Okay, thanks, Mark. Yeah. You mean when they want to go?
Repeat the question.
Sorry, could you repeat that? I could not hear you.
What happens when the customer swaps those SSDs across different hosts and different operating systems? Today, there is no restriction, right? You can move from one SSD to another one.
Okay, so yeah, if I understood the question correctly, it's what happens when the customer repurposes a drive and moves it to some other usage. Right now, they do have to be sure that the drives actually have similar characteristics. They might be coming from different vendors, but yes, that is still the responsibility of the customer to understand how it's configured and what they will have to do to possibly reconfigure it. So this is all things that will have to be worked out as we move into implementing this model. Does that really answer your question, though? Okay.
But if you reconfigure a drive through our feature here, it is data destructive, right? So you delete the endurance group, you delete the set, the data's gone.
Yep.
But you're repurposing the drive, so you're going to put new data on it anyway, right?
Yep. Okay. And here's one more. We didn't really talk about this example before, but in this case, very often you'll want a small amount of relatively high-speed SLC NAND, and the rest of the drive configured as QLC or TLC. So this gives what we're describing today, this capacity management gives you a way to do that. You would configure an endurance group in which all the NAND operates in SLC mode, and that's simply a firmware function change to have it operate in QLC mode. So it's easy to set off one piece in SLC and the rest of the drive operating in QLC or TLC mode. So this is something that is within the scope of what we've defined in the technical proposal. Any questions about this? Okay, thanks. So we've talked about how you would use this with SSDs, but we also have the storage box people working with us on this. They have different concerns. In their case, you're not necessarily just using NAND sitting behind the abstractions of a namespace. They may actually be using spinning disks. So they don't want to get down into those details. So we gave them a different model. They don't need to specify media units. They're more interested in domains and as they call it, and partitions, which is part of this other technical proposal. For that, we have a model of operation called variable capacity management. There's just the big failure domain that has some media assigned to it, and the host, when configuring a endurance group or NVM set, simply requests a certain amount that's going to come from that, all the backing storage in that domain, and they don't need the little details that we were showing you for the media units. But I'll go into that in somewhat more detail later. Okay, so as you've sort of inferred by now, we have these two methods. The first one we're calling fixed capacity management. That's primarily intended to be used for SSDs. And then what I was just mentioning is variable capacity management. I'll go into variable capacity management pretty much at the end. Okay, so fixed capacity management, basically what we're doing right now is what the interface will do is present a number of fixed configurations. Each configuration will specify all the media units on the drive and how they are combined into endurance groups and NVM sets. The intent for right now is that when the drive is first provisioned at the customer site, or possibly before it ships, you would select one configuration that would configure the entire drive, and it would stay that way for the rest of its life. Now, it will be possible someday, we think, depending upon the experience we get actually using this in the field, well, maybe you want to add pieces incrementally out of the storage. But for now, we're starting with the simplest case, which is go select the configuration that you want. We've determined this satisfies the requirements of the hyperscalers. This incremental configuration, like I said, where you add an endurance group now and then add another one later until you've provisioned all the capacity, we're not going to do that right now. Also,
it's a testing nightmare. There's so many different combinations.
That's right. And to go a little bit more into that, it looks like there's still going to have to be a conversation between the drive vendors and their customers about, well, what is the specific configuration you need? And so, we would present whatever set of configurations they want. We're not going to get away completely from vendor-specific firmware, or sorry, I should say customer-special firmware, but this will allow us to have, a lot of the same configurations just replicated across different special firmwares. And it should still reduce the testing for the SSD vendors.
Yeah, lots of time.
And unfortunately, we have lines drawn across here, so I'll try to ignore those lines.
Those aren't in the PDF, if you download the PDF from the app.
Okay.
This is a Windows Apple thing.
Oh, and it's running on a Macintosh. That's the problem, yes. Okay, so we have one new command here called capacity management. The first operation we have one operation basically, like I said, for SSDs, which is select a configuration. There are other pieces that go behind that. We'll talk about those later. For storage arrays, there are 4 operations. Create an endurance group of a specified size, delete an endurance group, create an NVM set inside a specified endurance group, and the NVM set is of a specified size, and then also delete those. And for what it's worth, when you delete an NVM set or an endurance group, you delete everything that's contained by that. If you delete an NVM set, all the namespaces that were created inside of it are gone. They may have been deleted individually prior to invoking this, but they would be deleted then. Similarly, if you delete an endurance group, all of the NVM sets that were in it, and therefore all of the namespaces that were in it, are also deleted. Okay. Sorry, yeah, yes?
How do you maintain the fixed capacity in face of, say, die has failed or there's a wear leveling issues?
What do we do about wear leveling issues and if there are generally failures? There are a number of ways to answer that question. Right now, it would, in principle, be possible for the available configuration to reflect the loss of media units. Whether a vendor chooses to implement that is a different question. Also, when you, one thing, a big complication is if you, for example, have that dual NAND mode I was talking about where you have some SLC and QLC, the wear characteristics in those two different endurance groups are going to be very different. And so it will be, there will be a fair amount of work required before you could get rid of that, delete that configuration and reconfigure in another one where, for example, maybe everything is TLC. Because then the wear is going to be different, and there are a lot of computations that have to be done. We don't know that there are going to be demands for that, so we're not, and we've tried to avoid specifying stuff like that in this proposal. Does that answer your question? Okay.
There's another question.
Yes. Right. Right. That's right, and there's no, as you'll see when we move on, for the fixed capacity, we do expose the amount of the wear within an endurance group. We don't.
And down to the actual media units as well.
That's right, yes.
And your typical drive has one domain,
Yep.
right? It's not a multiple
Right.
thing. Yeah. Storage arrays have multiple domains.
Right.
Yeah.
Right.
We're-
Doesn't make sense for a user of a storage array to manage the endurance of volume.
Exactly. Yeah. So we have to be flexible, and that's
Yeah.
this feature is very flexible.
And we
kept having people come in and say, "No, that doesn't work for me. Do it this way."
we have had.
Absolutely.
Right. So what you may be doing is simply saying, just ask me for a namespace, and I'll create a namespace with the existing command, and that's fine. But we have had requests from other storage vendors to allow this, so they might create a number of separate endurance groups, and then within that they have to carve out the namespaces. So there are people who feel there is a use case for that. Any others? Yes, sir. Yes.
If there are need to issue a security risk command to securely get rid of data, or is it part of this?
The question is, what about secure erase? At this time, we have not specified any interactions between the NVM format command, which has secure erase facilities, and what happens here. Now, if you want to do a sanitize, which is every piece of media in an SSD, for example, in the NVM subsystem, that is required to work as it was before. So there's no implication that this is necessarily erasing any user data. So those remain separate orthogonal concepts. So we're not, once you start trying to work sanitization into something like this, it becomes very complicated. And we want this to remain as simple as it can. Okay. Any others before we move on? Okay. So we have about 20 minutes left. Okay, so there is a log page that will present a set of configurations that if you're using the fixed capacity configuration, the host can issue the command to choose one of those. Well, what are the pieces that are used to describe how the drive is configured? Well, we already talked about we have a controller, we have channels with media units hanging off of it, and you want to configure that into endurance groups, and within the endurance groups, say, configure sets. So at the top level, we'll have a number of different configurations. Within each configuration, we describe it sort of in this top-down manner. A given configuration will have, in this case, 2 endurance groups. And that's the first thing. So within an endurance group, before I move on from that, there are some characteristics that may vary from one endurance group to the other. One is the capacity adjustment factor. If you're a UFS person, you'll recognize this. This is how we express whether you're using, say, SLC, TLC, QLC. It's essentially how much of your available capacity is going to be consumed to configure this much storage in a particular, as SLC or QLC or TLC. You, for example, will use up, up to 16 times as much space configuring a media unit as SLC as you would if you were configuring it as QLC. There is total endurance group capacity, how much capacity is in this endurance group. There's spare capacity, and some of you by now are recognizing some of these terms from smart data. And then there's an endurance estimate, how much of the lifetime usage, reads and writes, for example, have been consumed. Okay, that's general information for an endurance group. Now within that, you can have one or more NVM sets. Frankly, there don't appear to be many use cases for having more than a single NVM set in one endurance group, but that abstraction was already put into NVMe in NVMe 1.4. So there's a list of the NVM sets that are configured in here. Then we list the media units, but those are listed according to which channel are coming out. So each endurance group will have some number of channels, 2 in each of these cases, and then some number of media units that are hanging off of each one. So the NVM set identifier list will have an entry for this NVM set, an entry for this. The channel descriptor for this NVM set will have an entry for this channel and one for that channel, and then within each channel you'll have a list of media units. For example, this one and this one are attached to this channel in here, and this one and this one to this channel in set number 1. And this, as you see, it's flexible enough that we can have one channel shared across multiple NVM sets. Mike, did you have a question?
You said one or more NVM sets. I thought it's 0 or more.
Yes, correct. The question was, he said he thought it was 0 or more NVM sets, and yes, it is not absolutely required to configure an NVM set inside an endurance group. You can still create a namespace without specifying an NVM set. Okay.
That's by not supplying the namespace ID. In other
Right.
words, leaving it 0.
Yeah, the NVM set ID. Okay,
Oops, too far.
a little too far. Oops.
And back.
Okay, so what's the information we're saving for each media unit? Remember, a media unit may, at the finest grain, be a die, or who knows, even a fraction of a die, but whatever. Well, we have an identifier. We have an identifier for the domain, which is going, and these are fixed throughout the lifetime of the configuration. There's an endurance group identifier, which, in our initial use case, you'd configure it once for the lifetime of the drive, but again, these may change. So this is something it could change across the lifetime of the drive. Similarly for an NVM set identifier. Capacity adjustment factor, it depends upon this. We felt it was useful to put it in the media unit descriptor so you didn't have to go indexing back up the chain. Also for the media unit, we keep track of how much wear there's been, the available spare, the percentage used. And then finally, right now, I'm not aware of any use cases where a single media unit, a die, may be attached to multiple channels, but we do have the possibility of putting that in the future. So we have a number of channels, then for each channel, an identifier of which channel channels that media unit is attached to. Could you back up one, Mark?
Sure.
One point I wanted to make here is this is fairly flexible when in how much detail is presented. Rather than necessarily specifying all this, which may just swamp the customer with too much information, perhaps the only thing that's listed is a number of different configurations with no information about what's inside of that. Now, if the customer's been having conversations with the SSD vendor, they'll know, the number, the identifier for the particular configuration they want, and they can just go choose that very simply. If you want to expose a little more information, then for each configuration, you might simply list only the endurance groups with this information for each endurance group. And then in that case, you wouldn't necessarily even list the channel, the NVM sets that are inside of it, or the channels that are used by an endurance group.
At least not in the interface. I mean, you
Correct.
can put it in a data sheet. You can put
Yes.
it in some proprietary documentation and
Yeah.
lock them in.
That's right. So,
Most of this is optional, right?
right. And the reason we're leaving it this way is we don't know the actual real-world use cases beyond the ones we know about already. But people may or may not need that much detail. They may need more. And so this whole structure can be expanded as we move forward. Yes, sir? Current maximum endurance groups, in principle, it's only limited by the identifier, which is a 16-bit quantity. So I seriously doubt we'll see an SSD that has 64K minus 1 endurance groups. But yes, each one could be different. Okay. Okay, so back to this. We're almost done. Does anybody have any questions about this or anything we've talked about today? Okay. The last thing then is to come back to the storage array case. We're calling this one variable capacity management. We say variable because the host will request a certain amount rather than selecting a complete entire configuration. The idea is, we said, dynamically create endurance groups, and then, if they wish, NVM sets inside those endurance groups. And basically, the operations I already showed you are carried out without actually presenting any information on what kind of storage is behind that. Could be SSDs, could be different speeds of rotating magnetic disks, whatever. But at this level, we don't, in this model, variable capacity model, we don't even expose that information.
And it's not typically needed by the customer anyway,
Yeah.
of those systems.
Right. Yeah, usage in storage arrays is very different. So the main points here are we have something that'll expose at different levels of detail how a drive can be configured. We've completely separated the creation of namespaces. All we do here is create endurance groups and NVM sets, and then the existing commands will create whatever type of namespace inside of that specified piece of storage. And again, we do things like that to avoid complications. Similarly, for not even addressing security issues like sanitization in this, we just the existing commands are sufficient for that, so we don't want to try to mix that in here. So this is what's coming. It's in member review at this time, so ideally there won't be very many changes after this, and hopefully within a couple of months you'll be seeing this published.
Yeah, NVMe publishes their TPs. No? Mike's shaking his head. You're not going to do that? All right, you can't see it. Sorry.
Yep. Okay, I stand corrected. We are now doing to NVMe what SCSI 3 did some decades ago, which is separate different command sets and different transport layers into different standards. And we're trying to contain the amount of confusion by holding off on the things we release until that's all done.
But you can always become an NVM Express member,
And see those, yes.
and then you get to see it.
Any questions? Any of those of you who know where the bodies are buried here care to dig anything up and make me address it? Okay. Well, thank you all very much.
Thank you.